Alright, so in this video we're going to talk about SQL injection. Some goals for this video here. We're going to describe SQL as a language. So in a previous video we did some of that, so we're going to do a little bit of review there and some of the commands and ways that we interact with databases. We're going to understand flawed implementations of it that can result in attack. And we'll figure out some of the methods that we can use to actually fix these flaws that lead to SQL injection. So some terms we'll go over here. Some of these may be review from before. Database is really essentially just, we can kind of view it as an Excel table, and that might be something a little bit more accessible. But a database is really a place where we're going to store stuff, store some sort of data. Inside of a database is an actual table. So like a database would be the full Excel document, and the table would be just one sheet inside of it. Columns inside of that table are sets of data of a particular type. So a column could be someone's first name, a column could be someone's age, someone's social security number, for example. A row is one single thing, one single item of that data type. So within a table, I might have a table for employee information, for example. In that table, I might have columns that have the first name, last name, email address, birth date, things of that nature. One specific row would contain all of those records, all of those columns for one entity, in this case, one employee. Some other terms specific to databases here. Primary key is going to be essentially a column that uniquely identifies that specific row. So primary keys often are just going to be a number, so some sort of numeric item. Think of your student ID as an example. That can be used as a primary key in our campus databases, since that is a number that uniquely identifies you. There might be multiple people with the first name Jason, for example, but there's not going to be multiple people with the same student ID number. Foreign key has to deal with multiple tables. So if we link multiple tables together, I might have a key in a second table that is actually a foreign key for a different table to link those two things together. DBMS, Database Management Service or System, that is the actual software that's going to interact with the database itself. So we have a database, we have a language called SQL Structured Query Language, or SQL, however you want to pronounce that interacts with that database, and that happens through a DBMS, or the whole system there. So in practice, what some of these things look like here, if I have this small little table here, so we'll say the database contains this table called users, and within that table called users, we have two columns. One is ID, one is username. So each of those columns has a name, and within each of those columns is a row. So each of those has a row there. In this case, ID might be used as a primary key, since that's going to be something unique, something specific that will identify that row. Only one row will have the ID of 1. So if we have databases and tables, how do we actually interact with that? Again, we're going to use structured query language to do that. That's how we're going to manage, how we're going to view, update, manipulate that data that's within a database. So we've talked about that quite a bit. In this video, we'll do a little bit more review of that, of what that language is. I want to point out one additional item that didn't make it in the last one. And then we're going to see how we can use all of that to perform the attack called SQL injection. So what we're going to do in SQL injection, the idea here is that we're going to take other commands that are not intentional for some specific query that's already set up to do something that we as an attacker might want to do, or attackers use it in this way. This is a common weakness. It is defined in MITRE's common weakness enumeration system. has number 89. Feel free to look that up. As far as securing against SQL injection, we'll get into some details as to how you can do that. But really, it all falls upon the programmers to do this. It's really going to be on the programmers to create their code in a way that is not vulnerable to SQL injection. A couple high-profile examples here at the very bottom of the page. So these are interesting since how they work here. So HB Gary is a technology security firm. You'd think if they are a security firm that they would be pretty secure themselves. They were actually broken into by LulzSec using SQL injection in their website. That's an oops. A similar kind of oops thing or funny thing here is mysql.com, which is a specific version of a database or a specific kind of vendor there. Their homepage was compromised using SQL blind injection. So again, similar SQL injection. This doesn't look good when you're a security firm or you run SQL or run a specific database and you are compromised using this technique. So it's a big deal. So some SQL basics, we've went through all of these, so I'm going to breeze very quickly through most of them. There's one more that we'll look at. So creating databases, creating tables, create database and create table to actually create those things. Again, databases will contain tables, which contain rows and columns of data. To actually insert data into a table, we're going to use the insert command to do that. So insert into the name of a table and then what we want to actually insert. Modifying data, we'll use update to do that. So this is if we want to change something that's already there. Update the name of the table, set something, and then where something equals something. So what condition do we want to actually set these things? So in this example at the bottom, we're updating the customers table and setting first name and last name to Sean and Zwak, where the ID is 1. So only one row there. If I did not have the where in here, if we just did update customers set first name Sean, last name Zwak, every single row in that table would become Sean Zwak, which is not ideal. Viewing the data, we'll use select to do that. Just select the name of the columns from the table. Filtering, we'll use a where if we want to filter that out a little bit more. So instead of gathering absolutely every row, we can select specific rows. This one we did not cover in the last video, so I do want to spend some time on it, since this will be used a bit in SQL injection. Union is a command that we're going to use to combine results of 2 or more select statements. The biggest component with unions is that the number of columns has to be identical. So we're going to use this to take advantage of an existing select statement. We'll add on our additional select statement, and we can kind of combine the data there. So in this example, we have the first select statement here. It says select first name from customers. I'm also going to select first name from employees and use a union to put those things together. So the resultant set, what I'm going to see at the end here is the first name from customers and first name from employees both. Deleting records, removing single records or multiple records from a table, we're going to use delete. Be careful with this when you're deleting things. Of course, it goes away. Not really a way to get things back. Dropping a table, this is going to delete an entire table or an entire database. This is more than just single records from a table or rows from a table. This is absolutely everything. Comments, again, we're going to use these quite a bit. These are things that are not interpreted at all. One thing to note on here is that comments, the syntax will vary based on the specific server you're using. So Microsoft SQL Server will use a dash. MySQL Server will use the pound or octothorpe or hashtag, whatever you want to call that. That will be useful. Multiple statements, again, we can put multiple statements together with a semicolon to do multiple things. All right, so SQL injection. Let's actually get into this now. How does this actually work? So we're going to say we have a website. And on that website, we're running a query to locate a specific user. So maybe on the website, it's asking for you to enter a user ID, and then we'll get all of the information for that user based on that user ID. In the code on the server itself, we might have something like this. So we'll have this query here. You should understand it at this point. So it says select star from users. So we're going to get all columns from users where the user ID is a specific user ID. Now all that syntax at the end, we'll talk about that in a moment. So query, this is just a variable in the code. So we could say this is possibly PHP code as an example. And this variable is what is going to contain this SQL command, in this case, this select statement. So this whole select statement here. This portion, everything in between those outer double quotes, is that string that is going into this query variable. First part here, select star from users. Again, that's going to select all of the columns from that database or from that table, from the users table. And then how we're going to filter that, instead of selecting every row, we're going to say where user ID equals web underscore user ID. So this component in here, that is a specific variable. So that's another variable here. So we saw $query is a variable. $web underscore user ID is another variable. So in this PHP code that we're looking at, let me see if I can do a little bit of drawing here. Pen. So we'll see kind of from, let's say here to here. That is another variable, another thing that we're going to enter in. So where we see these periods right here and right here, that means concatenate. So if I clear this out, I wonder if that'll clear it. That does not clear it. Eraser. This is more difficult to erase than I thought. All right, so this is just going to concatenate or put multiple strings together. So from these double quotes, from right here all the way over to right here, the very beginning. So that's like string number 1. Dot is going to be whatever this user ID is. And then in these last double quotes is the end of it, which is just a single quote. Now we'll talk about those quotes in a moment. Now this web underscore user ID, I mentioned that's a variable, and this could, for example, come from the user's computer. So here it says post underscore username. What that is in this case is a specific variable that is in the post request from the web server. So if the user is logging in, for example, their username would be filled in when they click the enter button or the login button for web underscore user ID. So if web underscore user ID, for example, then is Sean. And I do have to thank Sean. We're working together on building some of these slides and getting hopefully the best content we can out to you. Anyway, so that's filled in with Sean. Then basically that variable is replaced with Sean. So again, with that concatenation that's going to happen between all of this is really just going to be taken away. And those strings will be shoved together. So it's going to look like this. So now our query says select star from users where user ID equals Sean. So that ID. One thing you'll note in here is these quotes. So I have a single quote here and a single quote here, and then a double quote over here and a double quote over here. So within this specific programming language, the double quotes define a string around, and they contain the entire query string itself. The single quotes you'll often see in SQL or SQL language that will surround any sort of textual variable or any text like that. So here you'll see it around Sean. Now, if we look back up for a moment, you'll notice the single quote and the single quote that were hard-coded into that string. They had nothing to do with the input. So when Sean's username was entered, those single quotes were already there. So that's how this should work normally. Now with SQL injection, instead of saying my user ID is Sean, if I change this a little bit and I say my user ID is single quote or 1 equals 1, that's going to change things. This is kind of the classic example here. So let's take a look at what's actually happening here. So if this gets replaced in, and I end up removing all these concatenation points here, I have a single quote here, a single quote here. So it will say select star from users where user ID equals essentially blank or 1 equals 1. Now we all know 1 does equal 1, so that's true, and that's going to evaluate to true, and that's going to be useful for us. That's going to be key. One other thing that this is missing is a comment. And we need a comment in here because of something I like to call quote math. So if I get rid of those two marks and we look at all of the quotes that are in here, our quotation marks need to line up and need to math out. So I have a double quote here with an ending double quote here. So those two have a partner. I have a double quote here and a double quote there, a double quote there, and a double quote there. So all my double quotes have partners. There should be an even number, always be an even number there. So I'll get rid of those. Now if we look at those single quotes, and again, those single quotes just surrounded that username that was inserted. So I have, and it's hard to see, but right after user ID, a single quote there and a single quote there, because I inputted that single quote as a part of the username here. Now I need that single quote to finish off this component here because I don't really want to supply a user ID. I care more about getting this part of the query in so I can say true and select all users' information is what the idea. Now continuing on though, I see this other single quote out here, and 3 single quotes does not add up. The math does not work. So we have to figure out a way that we can maybe get rid of this last single quote out here. And it just so happens this is where comments come into play with SQL injection. So if I change my query here, or my user ID a little bit more, so I added in this semicolon and then this comment denote here, it changes things a little bit. So SQL queries always will end with a semicolon. So now what this query looks like, if I put all of this together, is this here. So select star from users where user ID equals single quote, so essentially a blank there, or 1 equals 1 semicolon, and that ends it. So then this comment thing here, that comment, basically I have comment single quote, and again, anything that comes after comments is not going to be evaluated at all. So that comment symbol essentially gets rid of that last single quote, so our quote math actually matches up. So within the query itself, again, if we verify, I've got single quote, and really that's it. So my quote map does match up. That is largely how SQL injection works. It's kind of the theory behind it, the code behind it. This is a simple example and a pretty common example to start off with. We'll get into some more examples with some of this in your homework and in future videos. I just want this to kind of be an introduction so you're starting to understand how this works. Now, how do we actually discover SQL injection here? So the idea of this course, while we need to know how these offensive techniques work, that's not really the whole goal, right? We do need to understand how these offensive techniques work so we can properly defend against them and set up our applications in a way that they are not vulnerable to SQL injection in this case. So how do we actually find these sorts of bugs and how do we fix them? Well, starting off with discovery, one thing we can do is source code review. This is actually reading through all of the code, everything that's behind every web application. Now, it's effective, it can be effective, but it's not always perfect. We're still relying on humans to look at code and humans to figure out if there's an issue. Largely, these issues will crop up if users are doing things like string concatenation, and that's exactly what was happening in that previous example. We were just taking some strings with some user-controlled input, putting it together, and throwing it at the database and hoping it worked. Now, if we require humans to do source code review and look at all of the code for everything forever, it takes a lot of time. It takes a lot of user time, and we need to pay someone to do it, so that becomes expensive. And because of that, it doesn't really scale well. There are some tools out there that can do some of this source code analysis for us. They are language specific, so depending on what programming language you're using, if you're using PHP for your website or some ASP.NET for your website, C# code, whatever it may be, there are some tools out there that can help with this. They're not always open source though. The open source options that are out there, they're not always the best. There are some limitations to them, and some of the more effective options are very expensive. And you can follow the link here on this page to the Open Web Application Security Project site, or OWASP, where they list out some of the tools. We can also do some analysis at runtime. So instead of looking at the source code statically, let's set up the website, let's set up the application, and try to interact with it. We can use a free tool called SQL Map, and I'll demo this in a future video as well. We might even look at it in an assignment, yet to be determined. We're going to look at using this tool to query against a live system. So this is just a quick kind of screenshot of some of the output of it. Again, we'll cover this more in depth and actually use it live in a future video. So if we're able to find some SQL injection, whether it be through actually doing it manually, source code analysis, or some dynamic analysis for a running website or a running application, how do we actually fix it? How do we prevent SQL injection from actually happening? Well, there's really kind of 4 major methods we can use for it, each of those listed here. So the first one is really going to be the best way to do it, to use prepared statements. With a prepared statement, what we're doing is we're putting in the code exactly what our query will be. So in that example, it's select star from users, where, and then we have a parameter. That parameter is the user ID. Now, this is going to depend upon the specific language you're using. Again, whether it's PHP, C#, whatever that may be, to actually deal with the implementation of it. But we're bounding specific variables to those specific spots inside of that query. The idea here is that the attackers can't change what the query is actually doing, since this is really just going to be used as a parameter inside of it. Everything else will always stay the same, has to stay the same, and those parameters can be filtered a little bit better. Stored procedure. This really happens very much the same way as prepared statements, but it's not necessarily inherently safe from SQL injection. Now, a stored procedure is another way of running a query, a repeatable query, on a SQL server. This is something that's set up on the server itself. You can set up the stored procedure and just pass in the name of the procedure and the parameters. The parameterization can help, but it's not necessarily a one solution fixes all with this one. Whitelist your input validation. So with this, we're looking at some specific parameters that can't necessarily be bound. So we might be looking at basically verifying some of the content that we're receiving from the user. If we visit that link, you'll see some examples here. So this is again on the OWASP website. So in this example, we have table name validation. So instead of asking the user what table do you want to view information from and leaving that open for them to manipulate in whatever way they want to, we can have a list of expected answers or possible answers. Now we can't do this for everything. This example, we have a switch for the table name. So I could say, do you want table 1, table 2? So in this case, it says foo table or bar table. But which do you want to work with, or what do you want as your answer for this query? I can't do this for everything. I can't necessarily query my database for all of the users and say, which user do you want to log in as? Because we're kind of spilling information at that point. So it's not, again, a perfect solution, but it does help and it can help. Escaping user input, this is kind of a last resort here. Now this is something that's going to be specific to the specific database that you're using. So that's a little bit more difficult to do. The idea with escaping user input is basically removing some of the components that are commonly used in SQL injection. So based on the, again, database that you're using, whatever the specific comment is, the actual character for that, maybe we have to take that out. So we never should see that, or we never expect to see that in a username, so we don't allow it, right? Actually purposefully filter that out. Same with single quotes and things of that nature. And that's one of the reasons why you might see password fields only allow specific characters, or they filter out specific characters. They might be doing something like this, escaping the input, so we only have things that we would expect here. All right, so those are the 4 methods here. That's going to end this video. Kind of a quick intro on SQL injection, some of the methods we'll use to detect it and fix it, to remediate the issue. We'll get a little bit deeper with some more hands-on examples of this content in a future video. In the meantime, if you have any questions, let me know. Otherwise, we'll talk to you in the next one.